Okay, I'll go over the first part of the review we did in class today, and then I'll post the second part. So number 17, we had to write the exponential equation in log form. So again, you just recall log base b of y equals x means b raised to the x is equal to y. Okay, so this will be log base 3 of 243 equals 5. Number 18, my base is 9, so that would be log base 9 of 1 equals 0. And number 19, my base is 1/3, so log base 1/3 of 27 equals negative 3. We had to write the log equation in exponential form. So again, keeping in mind this important relationship. Okay, so this would be 2 raised to the 4th is equal to 16. And then my base here is 10 even though it doesn't show, so that's 10 to the 1st is equal to 10. And here my base is 0.6, so that's 0.6 squared is equal to 0.36. Number 23, we're asked to use mental math. So again, we just keep in mind that very important relationship. That log, it always wants to jump around. That log base b of y equals x means b raised to the x is equal to y. So 7 raised to what is 49? That is 2, because 7 squared is equal to 49. Okay, 24, so 24, I'll just rewrite this. This is log base 1/2 of 1/4. 1/2 raised to what is 1/4? That's 2, because 1/2 squared equals 1/4. Okay, number 25. Notice here I have a whole number 12 and a fraction. For what I'm evaluating, anytime that happens, that will always involve a negative number. So let's see here. So you ask yourself, 12 raised to what? 12 raised to what is 1/12? So that would be minus 1. So that would be 1/12. So this answer here would be minus 1. Okay, number 26. Number 26, again, I'll just write this. So this is log base, not ln, log base 10, even though we don't show the 10. So log base 10 of 0.1, well, that's 1 over 100. So again, my base is 10. I have a whole number, and then I have a fraction. And when that happens, that involves a negative number. So 10 raised to what is 1 over 100? That's negative 2, because 10 raised to minus 2 is 1 over 10 squared. That equals 1 over 100. And so this would be negative 2. And then lastly, number 27. So 2 raised to what is 1? Well, that is equal to 0, because 2 raised to 0 is equal to 1. Okay, so that takes care of those problems. Now here we're supposed to express as a single log and then evaluate. So you have to remember your properties. Okay, multiplication or subtraction involves multiplication. So we have to multiply 8 times 6, so that would be log base 2 of 128. And then 2 raised to the 7 is equal to 128, so this would equal 7. Number 30, we have addition, so we have to multiply, so that would be log base 10. I have 2 zeros and 4, so that will make 6. 1, 2, 3, 4, 5, 6, or log base 10 raised to the 6. Using inverse properties, so that's just equal to 6. Number 31 involves subtraction, so I have to take log base 2, and subtraction involves division, so that's 128 divided by 2. That's log base 2 of 64. And 2 raised to the 5th, I believe, is equal to 64. 2 raised to the 6, so this would be 6. 2 raised to the 6 is 64. Number 32, I have log base 10 of 10 minus log base 10 of 0.1. I don't like working in decimals. I'll just write this log base 10 of 1 over 10. Okay. Subtraction involves division, so I have log base 10 divided by 1 over 10. Okay, well that's just log base 10 of 100, and that equals 2. Okay. And then number 33, okay, so we're supposed to write as a single log, which means we need to bring the 2 down in front using the power property. So that's 2 log base 5 of 25. Log base 5 of 25 is 2 because 5 squared is 25, so 2 times 2 is equal to 4. And then lastly, number 34. So we have addition. Addition means multiplication, so this would be log base 10 raised to the 5th times 10 raised to the 4th. Remembering your rules for powers, when you multiply a power times a power, you add the exponent, so that would be log base 10 of 9, which is just 9 using the inverse property. Okay, so that takes care of those. Number 36, let's find a common base. Here I have 3 1/9, so I have to ask myself, how can I write 1/9 as base 3? Well, remembering your rules for negative exponents, 1/9 is 3 raised to the minus 2. And so that's 3 raised to the x minus 1 equals 3 raised to the minus 2. The bases are the same. You set the exponents equal to each other and you just solve. So x minus 1 equals negative 2, x equals negative 1. And then lastly, number 40. Okay, you will have a problem like this on the test. It's a 2-part problem. First part, you'll have to find k. And then the second part, you'll have to answer the question using k. So let's look at this. So here I'm given an exponential growth function that the future amount is equal to the present amount times e raised to the kt. I need to find k, which means I need to set this problem up. Initially in 1940, I see that the whooping crane population was 22. Okay, so p sub 0 is 22. E raised, I'm looking for k, I don't know what k is. Okay, from 2003 to 1940, that's a total of 63 years, so the time expired was 63 years, and in 63 years it grew to 194. Okay, so that's how I can set that up. So we divide by 22. Okay, and I get 194 divided by 22, and that will give me, so 8.181818, on and on and on, equals e raised to 63k. Now I need to get rid of v. So again, how do we get rid of v? Well, we take the natural log of both sides. The inverse of v is ln. So we'll natural log both sides, well, ln both sides. So ln of 8.181818 yada 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 equals 63k. And then to solve for k, we just divide by 63. So let's do that with my calculator. I have 194 divided by 22. So I'll just repeat that. So I'll take natural log of 194 divided by 22, and then I'll divide that by 63. So that will give me 0.0346. 0.0346. So k is equal to 0.0346. I found k, so now I can answer the next question. If the flock continues to grow at the same rate, how large will it be in 2020? Well, let's see here. So 2020, the initial population started at 1940. That makes a total of 80 years that have gone by. So then p of t is 80, and then I have my initial population is 22, and I have e, and I know that k is 0.0346, and t is 80 years. Okay, so I'll evaluate that. So inverse e times 0.0346 times 80 times 22, and that will give me 350. So this would be approximately 350, what do we have here? Whooping cranes. Okay, so that concludes the first part of the review, and then I'll post the second part here in just a second.